In our final video for section 8.4, we're going to talk about graphing logarithms. When you graph y equals log base b of x minus h plus k, you're going to follow very similar steps to what you did when you graphed those radical functions, when you graph exponential functions. First thing you're going to want to do is rewrite the function with no h or k value. Remember, that's what we call the parent. So your parent function then is just going to be log base b of x. Now there's two things you're going to want to keep in mind. If the base is greater than 1, the graph is going to move up and to the right. You might get something like this, kind of like that. If the base is, however, between 0 and 1, you're going to get something that starts high and goes like this. Then the key, this is kind of a tricky one. You want to rewrite the log in exponential form and make an xy table, and you're going to end up picking easy y values to plug in, because you'll see when we write an exponential form it'll actually be easier to plug in the y's than the x's. You're going to plot points keeping in mind the characteristics of the graph, either meaning it's going to be like this guy or the original one, right? So either one of those, and shift accordingly. And we're going to be dashing in vertical asymptotes at x equals the h value. So lots of stuff to kind of look at. Let's look at a bunch together. First, y equals log of x. First thing that I'm going to kind of think of is, alright, there is no h or k, so I know h is 0, k is 0. So this is my parent function. I have no shifting. That's kind of nice. So we're starting off easy. My base, though, even though it's not written, I know this is the common log. My base is 10. So right now I have in mind the type of graph that's going to do this, since the base is greater than 1. So what I'm going to do now is rewrite the log in exponential form. So I know the base is 10, and if I raise it to the exponent y, I'll get x. Okay, so there's the exponential form. Now I'm on step 3. I'm going to make an xy table. Okay, pick an xy table, and now what I'm going to do is I'm going to pick y values to plug in. Now the reason why I'm doing that, guys, is because if you plugged in like 0 for x and 1 for x and 2 for x, you're going to have a hard time figuring out what y is. However, I can easily plug in like 0 for y, and I know x, if I plug in y is 0, that's just 10 to the 0, which is going to be 1. So I know x is 1. This is the coordinate 1 comma 0 that I'll end up plotting in a second. If I plug in 1 for y, I'll get 10 to the 1 is x, which is just 10. So I know I'm kind of working backwards here, but you're going to find it's a lot easier to plug in values if you plug in the y's for these log functions. So when I plugged in 1 for y, I got 10 as x. This is still the coordinate 10 for x, 1 for y. Now instead of plugging in 2, because I'm already kind of thinking if I plugged in a 2, that's going to be 10 squared for x. That's going to be 100. And that's just way too big. I don't want to plug in 2. But what I might do instead is I'll plug in negative 1 for y. So if y is negative 1, I'll get 10 to the negative 1 is x, which means 1 over 10 is x. That's 0.1, right? So if we plug in negative 1, we get out 0.1. So written as a coordinate, though, it's still 0.1 for x, negative 1 for y. Let's see if we can plot these on the graph. So we had the coordinate 1, 0, which is right here. When we plugged in 10, we got 1, so that's right there. And then when we plugged in 0.1, we got negative 1, which would be right here. So we plotted our points. We don't have to shift because our h and k is 0. My vertical asymptote is going to be the line x equals h, which in this problem is x equals 0. Guys, that's the y-axis. So what I'm going to do is I'm going to dash in a line here. There we go. I'm going to dash in a line right down the y-axis, except for that's a little bit too large there. Let me try this again here. Let's erase that. There we go. So this would be like my asymptote, and what I'm going to do now is I'm going to draw a smooth curve that goes next to that vertical asymptote, up and away, and over and to the right. It creeps up. This is not the greatest drawing I've done, but you can see just like kind of the exponential functions got closer and closer to a horizontal asymptote, log functions, since they're inverses, everything's kind of flip-flopped. They get closer and closer to the vertical asymptote as it goes to the left, and it never quite hits it, right? But it goes on and on forever to the right. So the vertical asymptote was at x equals 0. The domain is not all reals. I can't plug in anything I want for x. Think about it. There are no x values that I plugged in over here. The only x values that I can plug in are to the right of this asymptote, which makes the domain x values just greater than 0. You can't plug in 0. So my domain has all x values greater than 0. The range, I go all the way down to negative infinity, and if I go far enough over to the right, this does end up taking off to positive infinity. So the range is always going to be, for these functions, all reals. All real. Let's look at a couple more to get the hang of it. Okay, for part B. Now, this is kind of tricky. A lot of students will make the mistake when they see that -1 there, they think it's the h value, but it's really not the h value. And the trick is, if you look back at your first page there, the h value is in parentheses with the x, and it's the k value that's not. Now, since there's no parentheses like that, I know that that -1 is actually my k value. My k is -1, my h is 0. There is no h value. So again, the trick is the h is always going to be in parentheses. So if you don't have parentheses, it's not the h value, guys. Now, the first thing I'm going to graph is my parent. The parent function is what I'm graphing if I ignore that, right? So my parent function is y equals the log base 1/3 of just x. Now, my base is 1/3. That's a number that's in between 0 and 1. And if you looked at that first page, the characteristics of this graph, it starts high and it's going to go low. So I kind of have that in mind already, that's what's going to happen. What I'm going to do now is I'm going to rewrite this in exponential form. So the base 1/3, I should really put this in parentheses, to the power y equals x. This is my function in exponential form. I'm going to make an xy table, and remember, you don't plug in the x's, you plug in the y's. If I plug in 0, I get 1/3 raised to the 0, which is just 1. If I plug in 1, well, 1/3 to the 1 is just 1/3. If I plug in -1, 1/3 to the -1, if I distribute, would be 1 to the -1 over 3 to the -1, so it's just the reciprocal 3. So I have a few coordinates to plot. 1, 0. When I plugged in 1/3, I got 1, so that's about right there. And 3, -1, that's right here. Now, the parent function, if I were to graph it, would go like that. I'm going to undo all of that because that's not my final answer. What I have to do now, because my k value is -1, this means really shift down 1, right? So each of those coordinates, I have to move down 1. Let's maybe use a different color for my final set of coordinates. If I move that coordinate down 1, that coordinate down 1, and that coordinate down 1, my final graph starts close to the y-axis. Since we didn't shift horizontally, my asymptote is still the same, and I'm going to go down and to the right. So my graph looks like this. Let's talk about the asymptote. The asymptote is still x equals 0. The domain is only x values that are strictly to the right of that asymptote, x greater than 0, and my range, since I go all the way up to positive infinity, as I move to the right, this graph will eventually go downwards. I have all reals. This might be my last example for you guys in this one. Now here, because the negative one's in parentheses, I know that is an h value. Remember, the h value is the opposite of what you see, right? It's really what you're subtracting from x, which is a positive 1. So h is positive 1. My k value is 0. My parent is still, like the other function, log of base 1/3 of x. So this is my parent function. And just like the other one, it's going to have that same moving downwards and to the right type of graph. So remember, when we rewrote this in exponential form, we got 1/3 to the power y equals x, and I'm going to plot essentially the same exact points that we got here. So rather than do that all over again, let's just kind of rewrite them. Remember, we got 1/3 and 1. When we plugged in 1, we got 0. And when we plugged in 3, we got -1. Now, however, there's a horizontal shift. If the h value is 1, that means we have to go 1 to the right. So I'm going to take all of these coordinates and I'm going to draw it in black maybe this time. My final points, if I shift all of these guys 1 to the right, that first coordinate at 1/3 1 goes there. 1 0 becomes 2 0. That coordinate becomes that coordinate. Now, what used to be the asymptote along the y-axis is no longer the asymptote along the y-axis. That's been shifted 1 unit to the right. So I'd have to dash in a vertical line along x equals 1. So the asymptote has been shifted. Let's write that up. The asymptote, remember, the asymptote is always of the form x equals whatever the h value. In this case, it's 1. So make sure you move. If your asymptote moves, you have to re-dash it, right? So it starts up high along the asymptote, and I move down in a smooth curve through these coordinates, and it goes down and to the right. So our domain has been affected. Our domain now is all x values to the right of that asymptote, which is x values greater than 1. And the range is going to still be all real. What I'd like you guys to try at this point is the last maybe couple of graphs. You can try D, E, and F. Try your best on this. The one note that I'm going to say for part F, if you take a look at that last one, guys, your parent function, if you ignore the shifting, right, you're looking at y equals ln of x. What's the base? What is your b value? If it's ln, hopefully you're saying it's just e, which is greater than 1. It's about 2.7, right? So this type of graph at the parent function should kind of go something like this. So keep that in mind, and I might even do you one more favor. If you wrote this in exponential form, the base e raised to the y equals x. And I'm actually okay if when you make your xy table, if you want to let e be approximately 3, I'm good with that. So if you want to use 3 to the y equals x to plot your points, that would be fine. Good luck with these graphs, guys, and we'll check them tomorrow.